and welcome to Know Physics with me. Hope you are doing good. Yes. So we have started with Physics CBSE class 10, chapter 10, light reflection and refraction, and we are almost done with the whole chapter. So we are yet to discuss book-in questions as well as book-back questions. So numericals we will cover it separately. So theoretical part questions we will try to cover in this session. Okay, both book-in as well as book-back questions. Clear? Yes. So let's start with the first question of page number 168. Okay, define the principal focus of a concave mirror. Okay, so the question is we have to find what is principal focus in the case of concave mirror. So how will you define principal focus? Parallel rays after reflection, they meet at a point, that is nothing called as principal focus, yes or no? So the definition you can write like this: the rays which are parallel to the principal axis after reflection by the concave mirror converge at a point, and that point is nothing but called as the principal focus of concave mirror. Converge at a point or meet at a point, anything you can say. Okay, yes. Third question, second question is a numerical question. We'll cover it in differentiation. Okay, name a mirror that can give erect and enlarged image of an object. So the hint here is it should produce erect and enlarged image. For plane mirror we will have erect but same size image. For convex mirror we have erect but diminished image. Only for concave mirror we will have a chance of getting enlarged image. Yes or no? And that also first 5 positions we will have real and inverted image. Only for the 6th position, that is between P and F, we will have virtual and erect as well as enlarged image. So the answer is concave mirror between the point of P and F. So the question is only name the mirror. If they ask at which point you will get, you must mention that between P and F, when your object is placed, you will get an erect enlarged image. Okay. Next, fourth question. Why do we prefer a convex mirror as a rear view mirror in vehicles? So there are two main reasons why we are using convex mirror as a rear view mirror. One reason is, although it is producing diminished image, we get erect image. Okay, it is not inverted. Instead we get erect image. Okay, so this is one of the reason, and the second reason is it provides wider field of view. That means even though it is small, you can see so many objects covered in that small space. Okay, so you can see even big trucks or buses in diminished form. Okay, so it gives wider field of view. So the answer for this is, one is it produces erect even though diminished images, and second point is it produces wider field of view. Clear? Yes. Next is page number 176. First question, a ray of light traveling in air enters obliquely into water. Does the light ray bend towards the normal or away from the normal? Why? So what is the phenomenon here? It is a refraction because it is changing its medium from air to water. So what they are saying, ray of light is bending obliquely, so whether it bends away from the normal or towards the normal, and why? What is the reason for that? So from the hint given, air to water means it is moving from rarer to denser. So rarer to denser means it will move towards the normal. It will take the shortest path. Okay, so towards the normal. And the answer for why is because it moves from rarer to denser medium. So the speed of light in water is reduced when compared to that of air. So it bends towards the normal. Clear? Yes. Okay. Third question is based on the tabular column given before page. So find out from table 10.3 the medium having highest optical density. So highest optical density means denser medium. Okay, so which is having more refractive index, we say it as denser medium. So from the table we have to find which is having highest optical density and lowest optical density. So when you see diamond is having higher refractive index, so we say it as having higher optical density, and air is having lower refractive index, so we say air is having lower optical density. Clear? Next question is also based on the tabular column. You are given kerosene, turpentine and water. In which of these does the light travel fastest? use the information given in the table. So, you know speed is inversely proportional to refractive index, yes or no? So, for which the refractive index is more, the speed will be less. Here they are asking us to find for kerosene, turpentine and water while comparing in this which is having speed, highest speed, okay? So when you see kerosene it is 1.44, turpentine it is 1.47 and water it is 1.33. So which is having lowest refractive index will have high speed. So the lowest refractive index water is having, so obviously the speed of light in water will be the highest, okay? Next, the refractive index of diamond is 2.42. What is the meaning of this statement? So, refractive index, if it has means what you are telling it. It is a denser medium when compared to that the speed of light in vacuum, yes or no? So, you can say that the speed of light in diamond is 2.42 times lesser than the speed of light in vacuum. Clear? Yes or no? Yes. Next question, page number 184, first question. Define one diopter of power of a lens. So what is meant by one diopter? Diopter is nothing but the unit of power of lens. Yes. So you can define one diopter as, and how will you measure the power of lens? Using focal length. Power of lens is inversely proportional to focal length. Yes or no? And the unit of focal length is meter. So you can define one diopter as power of the lens whose focal length is 1 meter. So 1 diopter, 1d is equal to 1 by meter, 1 meter. Or you can write it as 1d is equal to 1 meter inverse. Okay, so this is how you have to define diopter. So diopter is the power of the lens whose focal length is 1 meter. Clear? Yes. Now we will go with book back questions, page number 185. Which one of the following materials cannot be used to make lens? So the options are water, glass, plastic and clay. So clay is the one which cannot be used for making lens. Okay. Next question. The image formed by a concave mirror is observed to be virtual, erect and larger than the object. Where should be the position of the object? So this we discussed just now, right? Yes. So what is given? Concave mirror. In concave mirror, you have only one condition where you will get virtual, erect and enlarged. Other all is real and inverted. Yes or no? So only one case we have virtual, erect and enlarged. That case is between P and F. Yes. So now try to compare with the options. Between the principal focus and center of curvature, no. At the center of curvature, no. Beyond the center of curvature, no. Between the pole of the mirror and its principal focus, yes. Okay. So the option is D. Next question. Where should an object be placed in front of a convex lens to get a real image of the size of the object? So there is only one position where the size of the image and size of the object is same in case of concave mirror as well as convex lens. In concave mirrors, it is at C, your object and image size will be same. Similarly, in convex lens, here the question is convex lens. So convex lens at 2f1. So the option is at the principal focus of the lens, no. At twice the focal length, yes. At 2f1 only, you will get the same size as that of the object. Okay, so the answer is second option. Next question. A spherical mirror and a thin spherical lens have a focal length of minus 15 centimeter. The mirror and the lens are likely to be. So listen to the question carefully. Using sign convention only we will solve this. Okay. So the focal length is minus 15 centimeter means it should be this side. X dash side. Yes. So minus 15 centimeter. So minus 15 is possible. For focal length to be possible, it is possible only in concave mirror, right? Yes or no? In concave mirror only your focal length will be this side, whereas in convex mirror your focal length will be on the other side. Similarly, in concave lens, your focal length will be on your left hand side. Whereas in convex lens, it will be on the right hand side. So in both concave mirror as well as concave lens, your focal length will be on your left hand side, that is negative. Okay, so the answer is both concave. Okay, yes. Next question, no matter how far you stand from a mirror, your image appears erect. The mirror is likely to be, options are only plane, only concave, only convex, either plane or convex. So think and answer. Okay, just by seeing the option, don't rush up and answer it. So the hint given is, when you stand in front of a mirror, your image appears erect. Erect means straight as if you are now. Okay, so in plane mirror, in front of plane mirror, if you stand, you will get erect image. Yes or no? Whereas in concave mirror, if you stand, you may have a chance to get real and inverted. Yes or no? So that option is left. You will get only erect images, they are saying. Yes. So the third option is convex mirror. If you check, there also you will get only erect image. So the option is option D, either plane or convex, you will get erect images only. Okay. Yes. Next question, which of the following lenses would you prefer to use while reading small letters found in a dictionary? So for normal vision, it is 25 centimeter, and we want converging lens, convex lens, to see nearby objects clearly. So convex lens, if it is 25 centimeter, we will go with that option. Since 25 centimeter is not given, just below that you check. So the options are a convex lens of focal length 50 centimeter. 50 centimeter, if you try to keep something, if you try to keep a book, you cannot read, right? Similarly, concave lens, no, we need only convex lens. Third option is convex lens of focal length 5 centimeter. Yes, even by keeping the book nearby, we will be able to read. Yes or no? So the option is option C, a convex lens of focal length 5 centimeter. Okay. Next we will go to 8th question. Name the type of mirror used in the following situations. So try to answer. First question is headlight of a car. So for the headlight of a car, what type of mirror we will use? We will use concave mirror because we need what kind of light? Parallel beam of light in order to cover more space. Yes or no? So we will need parallel beam of light, and that is obtained by concave mirror, and we will also receive bright light. So the answer is concave mirror. Second question, side or rear view mirror of a vehicle. We have already discussed, it is a convex mirror because it produces erect, although it is diminished image, as well as it produces wider field of view. Okay. And third question is solar furnace. So solar furnace, you will use concave mirror because the rays, parallel rays, converges at a point focus. Okay, that is required for solar furnace. Okay, so that is why we are using concave mirror. Clear? Yes. Support your answer with reasons. So these are the reasons why we use these mirrors for such situations. Okay. Next question. 1/2 of a convex lens is covered with a black paper. Will this lens produce a complete image of the object? Verify your answer experimentally. Explain your observations. So now, if you have convex lens, try to take convex lens and cover 1/2 of the convex lens with a black paper. Okay, black cloth or black paper. Okay, black paper. So now, when you try to look at an object through the lens, what will happen? You will find the same object will appear even if half of the lens is covered. Okay, you will get the entire picture of the image. But the difference is the intensity and the brightness of the image will be reduced. Okay, so even if you have small pieces, see, not only upper portion, even if you cover down portion and if you view the object through the upper portion, you will be able to see the image of the object completely, but the intensity and brightness of the image will be reduced. So the answer is, will lens produce a complete image of the object? Yes, the lens will produce complete image of the object. Verify your answer experimentally using ray diagram, they have said. So this is a ray diagram convex lens we have, and we are covering this portion with black paper. Okay, so ray parallel to the principal axis after refraction passes through the focus. A ray passing through the optic center. So here your image will be formed. Okay, so complete picture of the image will be formed, but the brightness and intensity of the image will be reduced. Okay, yes, and remaining all are numerical based question. We'll try to discuss in next session. Okay, so I hope you're all clear with the questions discussed now. Yes, so these all questions we will definitely be able to answer when we are thorough with entire chapter. Yes or no? These all topics are covered during our sessions from video 1 to 12, I guess. So if you have time, try watching all the videos so you'll get a clear cut idea of this lesson and you will be able to answer all the questions. Okay, so if you like the video, do share it with your friends, do subscribe my channel. So thank you for watching this video. Thank you for all the support given. Keep supporting. So thank you.